In this section, we're going to be solving triangles again. We're going to be doing that using the law of cosines. So the two triangles we're going to be working with in this section are going to be side angle side triangles and side 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 triangles. So typically if we are given a side angle side or a side 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 triangle, we're going to use a combination of law of sines and law of cosines. So here are the three law of cosines. Technically, just like the law of sines and the area of the oblique triangle, even though these all look a little different, they're all actually just the same thing. Also, you might notice, ignore the last little chunk being subtracted from each thing. Hopefully that looks familiar. That's actually the Pythagorean theorem, right? So law of cosines is, in a sense, a more generalized use of the Pythagorean theorem when we don't have a right triangle. So this is obviously for an oblique triangle once again. So we have a squared equals b squared plus c squared minus 2bc times cosine of a. And then notice the other ones are very, very similar. B squared equals a squared plus c squared minus 2ac times cosine of b. And then c squared equals a squared plus b squared minus 2ab cosine of c. So let's just jump right into the steps that we have to take. Just like the previous section, we need to first recognize what type of triangle we have. So if we have a side angle side triangle, then we know to use these following steps here. So step one, we are going to use law of cosines to find the side opposite the angle. Step two, we're going to use law of sines to find the angle opposite the shorter of the two given sides. Step three, find the third angle using a plus b plus c equals 180 degrees. So step three here is probably, and hopefully you agree, probably the easiest step out of these three steps. So hopefully, as long as you know the first two, the third one will end up being obvious. So that's for a side angle side. Now if you have a side 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 triangle, you're going to use the law of cosines first to find the angle opposite the longest side. Then you're going to use law of sines to find any other angle. And then the third step, once again, is the easy one. Find the missing angle using a plus b plus c equals 180 degrees. So it is important to make sure you're following these steps, like the shorter of the two given sides, opposite the longest side. That is important. If you don't do that, typically it will end up being incorrect. So even though memorizing steps can be very annoying, like I said for the one up here, side angle side, law of cosines to find the side opposite the angle, law of sines to find the angle opposite the shorter of the two given sides. Step three, hopefully it's obvious after that. And then for side, 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 once again though, it's law of cosines first to find the angle opposite the longest. We're finding angles for all of this one, obviously. So finding the angle opposite the longest side, then law of sines to find any other angle. So even though it looks tricky, there's only a few little things you have to memorize. Everything else after that is a little bit easier. So let's just jump into one example of both of these. So solve the triangle. B is 20, C is 30, angle A is 60 degrees. So let's say we weren't sure what type of triangle this is. Let's label everything so we can figure it out as we go. So side B is 20, side C is 30, angle A is 60 degrees. So you can tell by looking at this is going to be, we have a side, and then just going right in order, we have an angle next, and then we have another side. So just going in order here, no matter which order you went, clockwise or counterclockwise, you would end up getting a side angle side triangle, right? So based on the steps that we just saw on this previous page, that's going to be the first one, side angle side. Step one, law of cosines to find the side opposite the angle. So step one is going to be, let's just write down what we need to find first. I just always like to do that. We're going to find little a capital B, capital C. So step 1, we're going to use law of cosines to find the side opposite the angle. So that means we're going to find little a. So the issue, hopefully not too bad of an issue after I mention this, is when we're using law of cosines, we have to figure out which one we're using, right? We have 3 of them, but technically they're all the same thing. We just have to pick the one. So there's going to be an easy way to figure out which one we're using. I'll mention that second. If you picked the wrong one, you just wouldn't have all pieces of information to plug in. So you'd have to go to another one. So the easy thing to do is, since we're looking for side A, you're going to choose the one that already has side A solved for. So we're going to use this first one right here. A squared equals B squared plus C squared minus 2BC times cosine of A. So let's go ahead and write that down. If we were trying to find side B, then we would use the one that says B squared equals. If we were finding side C, we would use the one that said C squared equals. So even though this looks very messy, it's a lot of just plug and chug. Plug in all of these values. So B squared, 20 squared, C squared, 30 squared, minus 2 times B times C times cosine of angle A, cosine of 60 degrees. Plug all of this stuff in your calculator, and it looks like we end up getting 700. So A squared equals 700. Square root both sides. It looks like I rounded this to the nearest tenth. We get about 26.5. So even though law of cosines looks very messy, it's a lot of just plug and chug for the most part. Plug it in the calculator and evaluate. We get side A is 26.5. So we need to find 2 more things. So step 2, we're going to use the law of sines to find the angle opposite the shorter of the 2 given sides. So step 2 is going to be using law of sines to find the angle opposite of the shorter of the 2 given sides. So we have 2 given sides, B and C. The shorter one is 20. So that's for B. So we're finding angle B. Find the angle across from the shorter of the 2 sides. So we're going to find angle B using law of sines. So that's going to be B over sine of B. And it looks like we have to use A over sine of A because we don't have angle C yet. So we can go ahead and plug everything in. That's going to be 20 over sine of B equals 26.5, which we just found a second ago, over sine of 60 degrees. And this is when law of sines is a little bit annoying when you're looking for the angle. We need to cross multiply, if you want to think of it like that. Multiply sine of B to the right, and then multiply sine of 60 degrees on both sides. So multiply that to the left, and then we can divide 26.5 to the left. And then to find B, this is when we need to do sine inverse of 20 sine 60 degrees over 26.5. So let's go ahead and plug this in the calculator. And I'm just going to round this to the nearest tenth again. We get about 40.8 degrees. And then for the last step, as always, when we have side angle side or side triangles, the last step is always going to be finding just the third angle, which is probably the easiest, step 3. It looks like the only angle we have left is side C. So A plus B plus C. You could technically use law of sines here like we just did a second ago, but hopefully you agree that's a little bit more annoying. So we're going to go ahead and do A plus B, which we just found, plus C, which is what we're looking for, equals 180 degrees. So add A and B up on the left, and then subtract it on both sides. So 180 degrees minus whatever A plus B end up being, 100.8. We end up getting 79.2 degrees for angle C. So once again, just a quick little recap of what we just did. We recognized it was a side, angle, side triangle. As soon as you know it's side, angle, side, you know that we're going to do law of cosines first for the side opposite the angle. Then step 2 is law of sines for the angle opposite the smaller side. And then step 3 is just find the missing side using a plus b plus c equals 180. So yeah, very annoying for like these little steps, but if you know them, it works out perfectly every single time. All right, so let's see one more question here. We want to solve the triangle where a is 6, b is 9, c is 4. This one's probably the most obvious, that this is side, 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 right? Side, side, side. There's no angles here, so we don't have to worry about any like weird combination of angle, side, angle, 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 side, or anything like that. We just have all 3 sides. I'm just going to go ahead and label them. So we have 6, 9, and 4. And then let's scroll back up to that first page so we can run through the steps. So let me just write down, we know this is a side, side, side triangle. And we want to find just all of the angles, A, B, and C. So the good thing is, just like we kind of talked about when I was highlighting stuff, even though the steps are a little bit more detailed for what you actually have to do, like what you're actually finding, anytime you have a side angle side or side 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 triangle, you're doing law of cosines first, law of sines second, and then finding that missing side after. So even though the steps are a little bit different for what you're actually finding, the rules and laws you're using are the same in the same exact order. So side, side, side says we're going to do law of cosines first to find the angle opposite the longest side. Obviously, we're looking for an angle because that's all that's left. Law of cosines opposite the longest side. So let's go ahead and scroll. So we're going to find the angle opposite the longest side. The longest side is B. So that means we're finding angle B. So this is where it gets tricky because we're using law of cosines. So when we're using law of cosines and we scroll up here, the only angle that you see is the one that's in the input for the cosine. So that means we have to use this second one because that's the only one with angle B, right? So b squared equals a squared plus c squared minus 2ac cosine of b. So let's write that down. And then let's go ahead and plop everything in. So 9 squared equals 6 squared plus 4 squared minus 2 times 6 times 4 times cosine of b. So not as easy as when we were finding the side using the law of cosines. We first need to solve this for cosine of b, and then we can go ahead and do cosine inverse of the other side. So since we have our calculators, let's do a couple steps in one. 81 or 9 squared is 81. I'm going to go ahead and add these together too and do 36 plus 16. Subtract that to the left-hand side. So 81 minus 36 minus 16, we end up getting 29. And then just multiply all of these values together here. Negative 2 times 6 times 4 is negative 48. And then divide both sides by negative 48. And we're left with cosine of b equals 29 over negative 48. So once again, even though this looks messy, we do have our calculators. Hopefully you can kind of do a couple steps in one to clean it up a lot more quickly. And then we're going to do cosine inverse of negative 29 over 48. Plug that in the calculator, and we end up getting 127.2 degrees. So angle B is 127.2 degrees. And in my opinion, that's the most annoying part of this question, because now the next part is going to be use law of sines to find any other angle. So what I would do for this is side, side, side. Just know law of cosines opposite the longest side. And then after that, you can probably figure out what you have to do. Just know that it doesn't matter like what you do. There's no weird order that matters. You just have to find the other two angles. And you know that we can use law of sines, and then we know that we can use a plus b plus c equals 180. So we just did law of cosines. For the next one, find any other angle. Let's go ahead and find, it doesn't matter, let's find angle A. So law of sines says a over sine of A equals, we need to use b over sine of B because we don't have angle C just yet. And plug everything in. This is going to be 6 over sine of A equals 9 over sine of 127.2 degrees. And then solving this, just like we've done a million times here, I'll kind of skip to solving it. We get sine of A ends up equaling 6 times sine of 127.2 degrees over 9. And then we're going to sine inverse both sides and plug this in the calculator. And plugging this in, we end up getting 32.1 degrees for angle A. And then the easiest part, hopefully you agree with part 3, finding side C. That's just going to be, you could use law of sines if you really, really want to, or missing one angle, a plus b plus c equals 180 degrees. I'll skip plugging it in. Here's angle B, here's angle A. Solve this for C, plug them in, solve this for C, and you end up getting 20.7 degrees. So we had 3 sides. We just figured out the angles using law of cosines, law of sines, and then a plus b plus c equals 180 degrees. So even though with these 2 sections, law of sines section and law of cosines section, it seems kind of annoying because we have to determine what kind of triangle is given to us. Technically, we work with 5 different kinds of triangles, but 2 of those 5 we solve the same way. So really, there's only 4 techniques that we're using to actually finish solving all of these triangles. So it looks a little bit worse than it is. Just know that we have to use most of the time law of sines and then sometimes law of cosines first. All right, so that is actually it for this section.